I can't be there today. I just want to make sure that we're starting off on a good note. So we're going to start by looking at what we did on the very first day of trigonometry when we were looking at a bunch of different triangles, and all the angles were the same, but the sides were different. And that's the basis of right triangle trigonometry, is that corresponding angles, when you have triangles, corresponding angles are congruent, but the sides are proportional. Okay, so, and just a reminder, when we are doing trigonometry, we want to make sure that our calculator is set in degree mode. So you want to scroll down, and if radian is highlighted, you want to go over to degree and highlight that by clicking on your enter key and then quitting out of that. And if I'm trying to find the sine of a particular angle, you say sine, and then 19.5 is the angle that you're going to be using in this first problem, and hit enter. For this particular problem, it says to round to the nearest 10th degree, so you would just use 0.3. So go ahead and pause this video and go ahead and start working on with your partner or with your table doing the rest of this. Pause the video. All right, well, welcome back. So we want to just go through, when you were doing this, you saw that the sine of theta, angle 19.5, the one that we have starred over here, was 1 over 3. So when we set up our ratio, 1 over 3 equals a over 9. And you found out that a was equal to 3. Since I have this triangle over here, 3, 9, I know that theta is going to be 19.5. We knew that from the last triangle, okay? So similarly down here, this was a similar triangle, 19.5 again, so is equal to w over 6. Multiply both sides by 6, sine is 0.3, so w is equal to, or 1/3, so w equals 2. All right, and similarly again, so sine of theta is 1/3, and or 0.3, and then the theta is equal to 19.5. So when we came to this last one, we saw again sine of theta is equal to 1/3, and we set up our relationship. I know that theta is going to be 19.5. Now, we can do that on our calculator. If I know that the sine is a particular value, I can just do, I can take the inverse operation, because when you're doing the sine of an angle, you're putting in the degrees and you're getting out what the ratio is. If I know the ratio, I can do the inverse function to find out what the angle is. So just above the sine is sine to the -1. And remember, when I raise something to the -1, when I'm talking about functions, it's the inverse function. So I'm just going to do second sine to the -1, and I'm going to put in 1 divided by 3. That's my 1/3, and I should get back about 19.5. Okay, so that is the basis of this lesson, is just understanding that inverse function. What we've been doing up till today is that we've been given the angle, we've been finding the ratios. Now if I know the ratio, I can put that into the calculator. So let's say that I know the ratio is 1 over 2, and I know that the sine of the angle is 1 over 1/2. I want to find out what the angle is. I can just go to second sine inverse, put in 1 over 2, and that's going to give me back 30 degrees. So a 30-degree angle has a sine of 1/2. That's what the inverse function is, okay? So teacher notes, if there's the faster way of sine -1 of 1/3 equals 19.5. So taking a look at our learning targets for today, the first learning target was talking about similar triangles. So, sorry about that. First learning target was looking at similar triangles, and if two triangles are similar, their sides are proportional, corresponding angles are congruent. This allows us to figure out angles from side ratios. Okay, so you can pause the video and get that into your notes. The second learning target is this idea of inverse trig functions. We can use them to find angle measurements from sides. The first step is to set up the equation. Then we're going to solve for the missing angle using the inverse function. So if I know that the value of the sine is 1/3, I'm just going to use the inverse function to do sine -1 of 1/3, and that's going to give me the angle measurement. Okay? So how about you go ahead and you start to check your understanding, and then I'll come back, so pause the video, do the check your understanding, and then come back and go through the actual solutions. All right, welcome back. I hope you did okay. So for this one, it says for each triangle, find the measure of the labeled angle. So we want to find the measure of angle A. So what I'm going to do is I'm going to give a star to angle A here, okay? And I know that the relationship of 7 and 8.6, that's adjacent and hypotenuse. So that gives me the cosine of A is adjacent over hypotenuse, so 7 over 8.6. So that's my ratio. I'm going to do inverse cosine of 7 over 8.6, and that gives me an angle of 35.5. This next one has you drawing a picture. A right triangle has a short leg that is 7 centimeters and a hypotenuse that is 13. And remember that concept of opposite the shortest leg is the smallest angle. So we want to draw a picture of that. There's my angle A. That's the smallest one. So that's 7 and then 13. So opposite and hypotenuse. So opposite over hypotenuse is sine. Sine of A is 7 over 13. So that's going to give me sine -1 of 7 over 13 is 32.6. And then to find the other angle, I'm just going to subtract it from 90. So that gives me 57.4. This last one is actually based on a true story. Some of you might have seen the movie. I think it was called Sully. Tom Hanks played the pilot. So this was a true story. And thankfully, because of the pilot's quick thinking, there were no fatalities. So we're drawing a picture to model this solution. So there we got the diagram. Here's the airplane, and the airplane narrowly missed the George Washington Bridge, flying at a height of 1106. So there's 1106 feet. And it said here that from there, the plane landed safely in the Hudson River 6 miles away. This is in 6 miles. So since these two are in different units, I need to convert the 6 miles to 31,680 feet. So that might be one thing that you missed when you were doing this problem. And so when I did that, I found that the tangent that's adjacent and opposite, so tan theta is 1106 over 31680. So in that case, my angle is just 2 degrees. 2 degrees. All right, my friends, good luck on your homework assignment tonight, and I hope to see you soon. Bye-bye.